Hey there everyone. So I'm doing this on a Friday, which is when you're doing the work that I've asked you to upload before I go through. Now I am going to go through it anyway, even though I've not had a chance yet to see what you've uploaded to me, but I will try to put some feedback out there at some point personally on there. But also please watch this, and the reason I'm going through it now and not waiting a day to do it is because it leads so much into what we're going to be doing for the rest of the lesson, which is working through more similar problems, gradually getting a bit more complex. But before we get into that, let's have a different puzzle to have a crack at. So you may remember when we did, let's cover up the horror of the Knight's Tour, but when we did that, we did have a very quick glimpse of this rectangle. As I said, we might come back to this at some point. Don't worry about what that says about the options. That's for year 9, so I'll cover that up so we don't get confused. Now, the rules on this. We've got to divide the grid into a series of rectangles or squares such that every cell in the region is in the grid is in exactly one region. On top of that, there is only one number in each region. So what does that mean? Well, it means that this 5 I'm looking at immediately as being something I can do something with, because it can't be in the same region as this 3 here or this one. So we know it can't be part of a square like that or like that. It can't be going that way. It's got to be going sort of up here. And then if I look at this 3, is it possible that we could have 1, 2, 3, 4, 5 up there? 1, 2, 3, and 1, 2, 3, 4. Or it is, isn't it? One thing that I do know for certain is this 10 looking here, because it can't go down to the 2, so it can't be any part of a square. It's got to be a rectangle going along 10. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's 5. Oh no, that is exactly 10, isn't it? So I'm going to use colour to help me out with this. So I'm making this one a blue, and then I'm going to try to use some different colours as I go through it and see how I get on with that. I will show you my solution. Now, as far as I can see, this 2 could either be those 2 or it could be those 2. I don't know for sure yet. I know this 9 can't go all the way down there because it's hitting that 20. So the 9 going across here is going to be 9 of those squares, isn't it? And it looks to me, I've never looked at one of these problems before, as if the big numbers are where we're going to get the early joy. Again, I see this 20, this has got to, it can't go down there, so it's looking like we've got a rectangle that's 20 large there. So that looks like a nice place to get started on that. If you fancy that, certainly either copy it into squares in your book, or probably copying it into squares in your book is probably a good idea. See if you can spend 10 minutes or so sorting that out. It's a really good way to train your brain into solving the kind of abstract problems that we have to in our maths GCSE, and also in life. Full of abstract problems, folks, full. Right then, so this was the question that I left you with at the end of last lesson. So as I said, I'm not sure how you got on with it yet, but see how you check out with this. So it says that they're mathematically similar. So we need to make the connection between 4 and 6. The scale factor will be what you get to multiply 4 by to get 6. So 6 divided by 4, well, that's the same as 6 over 4, which is 3 over 2, which is 1.5. So I'm going to be saying, right, multiplying by 1.5, or I'm going to do it today. You may well have done it in decimals, probably have, but I'm going to show you that because we're going to end up dealing with powers of things, fractions actually easier to work with when you start multiplying them by themselves than decimals. So we're going to see if we can do it all that way. So the scale factor is 1.5, or 3 over 2. the length factor will also be the same, which is how we got it, wasn't it? The area factor would be multiplying it by 3/2 squared. And we can square a fraction because we're doing 3/2 times 3/2 times the top. So 3 squared is 9 over 2 squared is 4. So that would be a factor of 9/4. And the volume factor would be 3/2 cubed. So that's what we'd be multiplying by. 3 cubed is 27, 2 cubed is 8. So we know that the volume of A is 80. So we need to multiply it by our volume factor, which is 27/8. And this is where working in fractions is quite nice, because if you're doing 80 is the same as 80/1, isn't it? So we can divide by the 8 to give us 10, and so the answer is going to be 10 times 27, which is 270/1. So the volume of our cylinder is exactly 270 centimeters cubed. So in the non-calculator paper, fractions are your friend. That's what I would always say, and I would never lie to you, not without a good reason anyway. Right, question 5's not got any pictures, and you might want to draw a little picture or two, I don't know. Anyway, pause the video, have a real think about it, think I'm going to find the scale factor, and then whenever it's area we're looking at scale factor squared, and whenever it's volume it's scale factor cubed. And it is a little bit different to anything we've looked at before. I am just going to draw a couple of cuboids just so that I can think about it. We've got x is smaller, isn't it? So I'm going to go for a cuboid looking about like that, and I'm saying the surface area equals 450, and then I'm going to go for a larger one that looks basically the same, x and y, and this surface area is 800 centimeters squared. Well, we are still going to be looking for the multiplier, but we've got to remember that it's going to be the scale factor squared because we're looking at area. So the first thing to do is say I need to find the number that multiplied 450 by to get 800. So we're going to have to do 800 divided by 450. And you might think, oh, this should be in the calculator paper. If it's these numbers, it's going to be the non-calculator, I'm afraid. This is where it gets a bit nasty, but it's not that difficult. Start off by simplifying it as much as we can. So I can divide top and bottom by 10. I can also see that I know you might spot that 15 goes into the 15 doesn't go into them both, so I'm talking nonsense there, but 5 goes into them both. 9 times into 45, and it's 10 to 50 plus another 6, 16 there, so it's 16/9. Right, so I can say that the scale factor squared is 16/9. So I want the scale factor is going to be the square root of 16/9. And the square root of 16/9, when we did our surds and stuff, what goes on with powers, we've done this before. It's the same as the root of the top over the root of the bottom. And the root of 16 is 4, the root of 9 is 3. And you know that's right, because if you do 4/3 times 4/3, you get 4 4s and 3 3s. So the scale factor is 4/3. And we want to know the volume. So the volume is going to be, we've got 1350 there, centimeters cubed. That's going to be multiplied by the scale factor cubed. So we're going to have to do 1350 times 4 over 3 cubed. Now, it's only 3 marks, might seem like a lot of work, but it's not actually that much. It's not that nasty. If you haven't done any of this so far, pause the video, make sure you've got it all copied and have a little go at it. I'm going to start by cubing both these numbers here. So that's going to give me 1350 times 4 cubed. 4 times 4 is 16, times 4 is 64, over 3 3s are 9, times 3 is 27. So I'm going to have 1350 times 64 over 27. Now for this to get, I could do 1000 and then divide, but actually if this is going to get any nicer, we're going to have to be dividing by what's on the bottom. So if you add the digits of this number, they add up to 9, and anything where, if it added, that means it's in the 3 times table, but it's also in the 9s. It works for both those times tables, just them. So I know 9 is going to go into both of them. So I'm going to cross 27 out and put 27 divided by 9 is 3. And then I'm going to separately do 1350 divided by 3. 3 doesn't go into 1. So into 13 it goes 4 times with 1 left over, 1 remainder. 3 into 15 goes exactly 5 times. So we've got 450. But I wanted to divide it by 9, so what am I doing? I could just do that again. Divide that by 3 and I get 1 with 1 left over, 15. Just to show you, because 3 3s are 9, bit of revision or something else. 1 9 in 13 with a remainder of 4 and 5 9s in 45. So however we get there, we know that this is going to be 150 9s, isn't it? Because we've still got the 0 there. So now I've got to do 150 times 64. Well, I think I'm just going to do 100 times 64 is 6,400. You could do it through long multiplication if you like. And 50 times 64 will therefore be half of that, 3,200. Add those together will get us 150 times 64, which would be 9,600 centimeters cubed. Is that my final answer? It's not, because I haven't divided by the 3 yet, have I? And I could have done that before. That would have made it. So anyway, dividing that by 3 gets me 3,200 centimeters cubed. But I'm sorry, folks. I don't know if any of you spotted this, but I could over here have said 3 goes into 150. So it's going in there 50 times. Then you only have to do 50 times 64, which gets you the 3,200 straight away, and that's because 27 happens to go exactly into 1,350. Okay, I hope that made some sense, and we move on to the next. This question is in 2 parts, so pause the video and give it a go. It's giving us our numbers in pi. Once again, this is not going to be a calculator question, so you're going to need to work in pi the whole time. They're mathematically similar, so what we know is that 4 times the scale factor is going to equal the length of q. That's what we want to know. So we need to know the scale factor. We know the area of p, 90 pi, if that was multiplied by the scale factor squared, we would get 810 pi. Now we don't really need to worry about the pi, because we could divide both sides of this equation I've made by pi, couldn't I? So I just need to think 90, how many 90s? The scale factor squared is going to be 810 divided by 90, which is exactly 9, isn't it? So if the scale factor squared is 9, the scale factor is going to be the square root of 9, which is 3. So you don't have to worry about the negatives, because that wouldn't make any sense with a real object, would it? So it's got to be the positive root of 9. So we are going to do 4 times 3, which means it is 12 centimeters long. So all the dimensions are 3 times greater in Q. We know that the scale factor is that squared, so we know that the volume, which is coming up in the next bit, is going to be the scale factor cubed. So the scale factor of P is 100 pi. P was the smaller one. So to work out the volume of Q, pause it and give it a crack if you're not, if you can, is going to be that multiplied by the scale factor cubed. And the scale factor cubed, 3 cubed, is 27. And if you do 27 times 100, you get 2,700. So it'll be 2,700 times pi centimeter cubed. If you put it on the dotted line, then let's put the units in there for you. Right, now here's a question. Pause it and give it a go. And before I go through how to do it, I'd just like to, for all those of you, I know there are quite a few of you who are still doing the work but not submitting it. It's really important that you submit something for every lesson, folks. I know it's probably annoying when it comes up as pink saying not submitted. You think, I think you've done it. It doesn't have to be all of every question at all. It just needs to be one question, maybe one that you had a bit of hassle on. It doesn't matter. You just need to upload some evidence that you are having a go at these and then marking it as you go through. If you do that, that gives me a much better much more evidence to support me giving you a good grade at GCSE, which I know so many of you deserve. Right, so what have we got? It's looking at surface area again, so that means we're looking at the scale factor squared, doesn't it? So 24 centimeters squared times whatever the scale factor squared is going to equal 96 centimeters squared. So if I divide by 24, the scale factor squared is going to be 96 over 24, and then we're going to want to do the square root of that. But before we do, probably a good idea to see if 96 goes into 24, and I'm pretty sure it goes in exactly 4 times. So if the scale factor squared is 4, the scale factor will be the square root of 4, which is 2. And that means that the height of the cone, which is a length dimension, so the height going from there to there, will be 4 times 2, which is 8 centimeters. The next part says the volume is 12 centimeters cubed. Work out the volume of the cone. So I'm just going to write up here of cone Q. So volume equals 12 centimeters cubed, and I'm trying to work this out. So pause it and give it a go. And hopefully you'll have got by now that this isn't as nasty as you might think it is. This is rated grade 6, by the way. So it's sophisticated but it's not totally confusing. So we've got our scale factor there, so we want to multiply it by the scale factor of 2 cubed. So we're talking 12 times 2 cubed is 8. 12 times 8 is 96. So your final answer there is that the volume equals 96 centimeters cubed. All right, hopefully that went quite well. Next time we shall move on to a new topic. Cheerio, everyone.